All right, I am continuing with the practice problems. Now it's the one that I wrote, because these are just kind of trying to get us used to section 2.1 stuff. So here we're just practicing with our slope of the tangent line formulas, aka instantaneous rate of change. So for each one, I want you to do the calculation at the specific number 3 and then something unspecified. I'll do the first one with the h and then the other two without the h. Your combination can be different. So for A, I could say the limit as h approaches 0 of f of x naught plus h minus f of x naught all over h. If I do this with the specific value x naught equals 3, I have f of 3 plus h minus f of 3 all over h. Now I need to use this specific formula. If I apply that to the quantity 3 plus h, that means 3 plus h squared minus 3 plus h minus f of 3, I'm going to check it's 6. Right, now it's just time for algebra, algebra, algebra. If I FOIL that out, it's 9 plus 6h plus h squared. If I distribute, minus 3 minus h minus 6 all over h, I notice that 9 minus 3 minus 6 cancels, and what's left in the numerator there would be 6h plus h squared minus h, which is 5h plus h squared over h. I'll do the formal step of factoring out the h, which cancels. I love to plug in, and I get 5. So if I were to graph that function, the slope of the tangent line at the point 3, 6 would have a slope, the slope of the tangent line is 5. Now the generic version would be the limit as h goes to 0 of f of x plus h, which is, well, x naught plus h. This is the very generic version of that function applied to something called x naught plus h minus the same function applied to x naught. Time for some algebra. FOIL. Distribute. Distribute. Be really careful about your minuses and stuff. If things aren't canceling, look for your mistake. So let's see what we got here. X naught squared minus x naught squared, x naught minus x naught. So anything without an h has canceled away. That will usually happen. If it doesn't, you've probably made a mistake. Everything left has an h in it. So I factored out the h from here and here and here, and then that cancels with the one in the bottom. I love to plug in, and I'm only plugging in for h. So I get 2x naught basically plus 0 minus 1. And we'll notice that's consistent with what we did before. If I plugged in 3 here, I would get 5. All right, the next one is g of x is 1 over x squared. So I could do the limit as x approaches 3 of g of x minus g of 3 over x minus 3. That would compute the slope of the tangent line at 3. So let's see what that looks like. G of x squared is 1 over x squared. G of 3 is 1 over 9. Now just got to do some algebra. Let's make a nice common denominator there. It'll be 9 over 9x squared minus x squared over 9x squared. Combine that, 9 minus x squared over 9x squared over x minus 3. These are doable. They just take a while. I'm not going to give you a ton on the test because I know they take a while. But after you do enough of these, you will really appreciate the shortcuts that are coming up. These are opposites, so they cancel but a negative emerges. So I basically have negative 3 plus x over 9x squared after the cancellation. I love to plug in. If I plug in, I get negative 3 plus 3 over 9 times 3 squared. That's negative 6 over 81, which reduces to negative 2 over 27. I can do it again abstractly. Limit as x approaches x naught of g of x minus g of x naught over x minus x naught. That's 1 over x squared minus 1 over x naught squared over x minus x naught. Steps are very similar, just now with an unknown instead of the specific number 0. Specific number 3. Common denominators as before. So I have x naught squared minus x squared over the product. Have a difference of perfect squares as I saw before. Factors like so. Oh, this 2 moved by accident. Again, these are opposites, so you can cancel them, but remember that there is a negative after you do that. So I can plug in. Wherever I see an x, it is now this unspecified x naught. So I have negative x naught plus x naught over x naught squared times x naught squared. So that's negative 2x naught over x naught to the 4th, and that simplifies to negative 2 over x naught to the 3rd. If I plug in 3, I would have a 27 in the denominator like I saw before. Okay, what was the third one? Root x plus 1. Here the function is called h. If that happens, using the version with an h in it gets awkward. I would say just change the name of the function so you don't confuse yourself. But I'm going to use the one where we just approach 3. So I'll use this version, h of x minus h of 3 over x minus 3. So that's the square root of x plus 1 minus square root of 3 plus 1, which is 2. It's a 0 over 0 limit with a radical, so I'm going to be thinking about conjugates. So if I multiply those conjugates up top, I would get x plus 1 minus 2 squared, which is 4. I'm going to leave that denominator factored because I think something's going to cancel. All right, let's notice that this numerator up here, if I simplify, is x minus 3, just waiting to cancel that other one. So I have the limit as x goes to 3 of 1 over root x plus 1 plus 2. Love to plug in. So I have 1 over root 3 plus 1 plus 2. So that's 1 over 2 plus 2, which is 1/4. And I can do this one abstractly. Limit as x approaches x naught of the square root of x plus 1 minus the square root of x naught plus 1 over x minus x naught. Let's introduce a conjugate. We'll just put a plus in the middle here. When I multiply up top, I get x plus 1 minus x naught plus 1. Let's put all that in parentheses so we subtract it correctly. you'll notice here the minus ones cancel. So our numerator is in fact x minus x naught, which will cancel with the x minus x naught in the bottom. So after cancellation, what I actually have here is just a 1 in the top over root x plus 1 plus root x naught plus 1. Can finally plug in wherever I see an x. I will now replace it with this, theoretically it's a number, I'm just not saying which one it is. X naught. And so a reasonably simplified version is like this. I really don't care if you rationalize your denominators. So, you know, the algebra here can be a little tedious. I'm not going to burden you with a ton of it on the test, but you do need to demonstrate that you can do it. And you definitely need to get those first steps correct to show me that you understand conceptually what's going on. All right, there were 2 more that I wrote. Let's just copy these and move them to the end. Why is this not scrolling? It's like there's something wrong with my finger. All right, so for number 2, explain what this represents. So this, you need to kind of represent, you have to notice this pattern. So you'll notice, what do we have here? We have theta minus pi over 3, tan theta minus tan pi over 3. You need to notice that that follows the pattern of a function applied to b minus a function applied to a over b minus a. That's an average rate of change. And then we're doing a limit here. That turns it into an instantaneous rate of change. And we'll notice that it's a limit where these are squeezing together. Theta gets closer and closer to pi over 3. This is our instantaneous rate of change formula, aka our slope of the tangent formula. You want to recognize that pattern when you see it. So one interpretation here is this is the slope of the line tangent to the graph of y equals tangent theta. Our input variable here is called theta rather than x, at theta equals pi over 3. Or you could say at the point pi over 3, and then tangent of that is specifically root 3. That's not necessary. If you just say what your input value is, that's fine. So we're recognizing that this is slope of the tangent calculation. We're saying very specifically which function it is and where on the graph we're taking that tangent line. And again, you don't need the y value, you can just say the input value. Right. Alternatively, you could have interpreted this as saying this is the instantaneous rate of change of the function f of theta equals tangent theta at theta equals pi over 3. Slope of the tangent and instantaneous rate of change are the same thing. It's just a question of perspective. But if you see something that follows this general pattern or follows the one with an h in it, you want to, so not only do you want to produce that when asked for it, but you want to recognize it when you see it. You want to notice, oh, this looks like slope of the tangent line. What specifically is it for? What function is it? What value is it? And then finally, one more. So here is the temperature of a frozen pizza in degrees Fahrenheit t minutes after it's been placed in a toaster oven. How fast is the temperature changing when t equals 8? So how fast sounds like a rate. Specifically at t equals 8, that's an instantaneous rate. Instantaneous rate of change is the same as slope of the tangent line. Here is 8. I will just do my best to draw what looks like a tangent line there. And I'm just going to make some estimates. So be careful about your grid. Oops. This here appears to be something like 8, 330. This here appears to be 10, 360. I just did my best. I'm using the grid. I drew something that looks like a tangent. So that slope looks like it would be 360 minus 330 over 10 minus 8, which is 30 over 2, which is 15. It doesn't look like 15, but the scales are very different. These are in the hundreds and these are low numbers. So the rate of change is the same as the slope, which is 15. And the units here would be degrees Fahrenheit per minute. All right, there we go.